video, we are going to be going over what the volume of three-dimensional shapes is, and specifically we're going to be focusing on rectangular prisms and cylinders. So to start, I want you to make sure that you've made a copy of the notes from our slides, and once you do that, you should have your own copy of these notes, and as you go through them, you should be able to type in them and fill them in so that you can keep track of your own notes. I'm going to be filling this in just as you will on the Google Doc, just so that you can see exactly how to type this stuff. I know math is hard to type on the computer, but since we can't give you the printed notes, this is the best that we can do right now. All right, so the definition of volume is the amount of space that is occupied by a figure, and some of those key words that tell us we're talking about volume in a word problem would be how much can you fit in an object, how much will the object be filled with, how much space does it take up, how much can it hold, the amount of what it holds, the inside of an object, so like it's what it's holding inside of it, what it contains, so think of like a jar containing soup, how much soup can the jar hold, and then we talk about it in terms of cubic units, and we'll talk about what that means as we go forward. So I have these pictures for you here. This is a picture of just a line, and it's measured in 1 unit. So this is just a measurement of length. But then we talked about, back in 5th and 6th grade, you probably explored what that means to talk about area. And area is just how much space a two-dimensional shape covers. So for example, think of like the tiles on your floor. How many square tiles would it take to cover your floor? And so we talk about that in terms of area. It's the area of your floor. We would get that by saying 1 times 1, and that would be a 1 by 1 square, so it's a square unit. And we write it as units squared. So we could say like inches squared, centimeters squared, etc., whatever you're measuring in, and we put that superscript of 2 or the exponent of 2 up top there. And now the new part that we're talking about is cubic units or units cubed, where we write the units with a exponent of 3 there, and it's a 1 by 1 by 1 cube, and that's our cubic unit. That's when we talk about volume. So basically, we're going to be talking about how many cubes could you fit into one item. So for example, how many cubes would fit into a larger cube? And the way I really like to think about it is like a Rubik's Cube. There's a bunch of little cubes in this one whole cube. So we'll talk about what that means. So we're going to be focusing on 2 formulas. The first formula is the volume of a rectangular prism, and that volume formula is V equals LWH. These L, W, and H stand for length, width, and height, and when they're written like this next to each other, we know that 2 numbers next to each other in math or 2 letters written next to each other in math tell us that we're multiplying those variables together. So whatever number you put in for L will be multiplied by the number you plug in for W and the number that you plug in for H. So you just multiply those 3 numbers together. So you'll see them like this. Length is usually how long it is, width is how wide or how deep that item is, and then the height is how tall it would be. Now, it doesn't quite matter which of the 3 dimensions you call length, width, or height because you're multiplying the 3 numbers regardless, so the order doesn't really matter here. However, this is just kind of the standard way that we would label length, width, and height. So one of the things I want to point out is if you click on here, I've made this quick little visual for you. And so this is what I was talking about when I said it reminds me of a Rubik's Cube. So this looks like a 3 by 3 cube that we would see as a Rubik's Cube. If you've seen a Rubik's Cube, it has the sides all different colors, but they're going to break this apart for us. And you can see how it's a 3 by 3 by 3. And so 3 times 3 times 3 is 27. So this would become 27 cubic units. So I'm going to go back just to this part. You can see if you were going to count, oops, I should pause that right there. If you would count all of these little cubes that this was just broken into, there would be 27 of them because we have 3 by 3 on the bottom. So the bottom row has 9. The middle row would also have 9, and then the top row has 9. So it's really like 9 times 3. And we get that by doing 3 times 3 times 3. So that's kind of a visual of what we're talking about when we say volume in terms of cubic units. It's like how many cubes could you get in there. Now for the volume of a cylinder, it's a similar principle. You're still trying to figure out how many cubes you could fit into this cylinder, but since it's a rounded object, it's a little bit more difficult to calculate. We have to consider that we would have a circle on top, and then it would be another circle and another, and it would just be a bunch of circles stacked on each other, and it would be whatever the height is of that. So you're taking kind of what's inside those circles and multiplying it by the height. So our volume formula is pi r squared h. So that means you're taking pi, multiplying it by the radius squared, and then multiplying it by the height. The reason that we have this is because the area of a circle is pi r squared. So if you just wanted to find the area of how much the top circle is taking up, you wouldn't multiply it by the height. But then since we're talking about the volume, that means that circle is being repeated h times all the way through this cylinder. So it's really being multiplied by h, whatever the height was. So some letters that you want to keep in mind here, V again means volume. Pi, we are going to just be using 3.14 as pi. So if you're using a calculator that has a pi button, please don't use the pi button because it's going to make you have to round a lot more, and you might not get the exact answer that we're going to be looking for in some of these activities that we have planned for you this week. The r is the radius, and remember that's half the distance of a circle. So if you would draw all the way across the circle, that's your diameter, but the radius is just half of that. So say your diameter is 10, you would divide it by 2, which means your radius would be 5. And then your height is just how long this side of your cylinder is. So the height never has to do with the circle. The radius is always what we want to focus in on the circle. The other dimension on the cylinder will be its height. Even if this was turned sideways, that line that's not part of the circle is still called the height of a cylinder. So something that I want you to do right now is click on this link where it says Desmos Scientific Calculator. And when you do this, it's going to open up in a new tab. And just like before, if you click and drag this tab, you can create a new window. I'm going to make that window smaller so that I can use this calculator while I'm doing the notes. And then I'm just going to make my notes window a little bit smaller so I can see them side by side here. So this calculator might help you with all these calculations because most of these are not going to be done in your head, especially when we're dealing with pi. So I'm just going to make this a little bit smaller so you can see. And we're going to go to page 2. So on page 2, it says solving volume problems for rectangular prisms. Step 1 will be to look at the formula sheet and write the formula. I've already done step 1 for you on each of these, just so you don't have to worry about typing in the math. In step 2, it says replace the formula equation with the appropriate numbers. In step 3, solve and label with the correct unit of measure. So in this example, I have a rectangular prism. My length is 10 centimeters. My width is 2 centimeters. And my height is 5 centimeters. So I'm just filling this in just to organize what my dimensions are. I already did step 1 by choosing which formula I would use. Since it's a rectangular prism, we're using length times width times height. So in step 2, I'm going to type in V equals, my length is 10. To show multiplication, I'm going to use a lowercase x. Just you can use that for today. The width would be 2, and then I multiply by the height, which was 5. So I'm doing 10 times 2 times 5 to get my volume. So that means that V equals 10 times 2 is 20, and 20 times 5 is 100. I didn't have to use my calculator here. That should hopefully be one that we can do. And now you can either label this as cubic centimeters, or if you want to be fancy, you can do 100, and then you can copy right below here if you want. If you highlight that and press Control-C on your Chromebook, you can put that label on it if you would like. It's up to you. This works just as well. Now in the next one, if you want to pause the video and try it on your own, feel free. I'll leave my example showing so you can try it. Otherwise, keep listening or press play when you're ready. So right here, our length is 7 inches, our width is 1 inch, and our height is 2 inches. So step 1 is choose the formula you're going to use, which is length times width times height. So V will equal my length, which is 7, times my width, which is 1, times my height, that is 2. So 7 times 1 is 7, 7 times 2 is 14. So volume here equals 14, and I'm just going to paste in my centimeters cubed there. Okay. So the reason I was telling you earlier it doesn't matter whether your length, width, or height is 7, 1, or 2 is because I could do 1 times 2 is 2 and then multiply it by 7, and I still get that answer of 14. So because you're just multiplying 3 numbers here, it doesn't matter what order you pick them in. So don't stress about that part. Now in the last one, this one's a little bit trickier. It's giving us that the volume is 96 cubic centimeters. So we already have the answer, but we need to find the length. So the width that they gave us is 3, and the height that they gave us is 4. We don't know the length this time, so we have one extra step to do. So my formula says that volume equals length times width times height. Well, I know that the volume is 96, so I'm going to say 96 equals length, which is L, because I don't know it, times our width, which is 3, times our height, that is 4. So now this becomes 96 equals L times 3 times 4 is 12. So now I basically just have 12 times L. And with multiplication, it doesn't matter what order you write it in. So I'm going to show it to us by writing it like 12 times L. And if you want, you can make this L italicized just to show that it's not a 1, it's an L. Now, to get a variable by itself, right now, 12 is being multiplied by L. I want L to be all by itself on this side. So on both sides of my equation, I'm going to divide by 12. So I can say divide by 12. I'm going to write it in parentheses here. It's hard to type math on here, so I'm going to have you write divide by 12 on both sides. When we do that, 96 divided by 12 is 8. And I did not move my calculator over enough, so you can see 96 divided by 12 is 8. So on this side, when I divide it by 12, I end up getting 8 equals, and if I do 12 divided by 12, that means that 12 divided by 12 is 1, and I'm left with 1 times L, and 1 times L would just be L. So 8 equals L. So that means that the length here is 8, and we're going to label it with centimeters because that's what our other measurements were in. So that missing length was 8. The way you could go back and check it would be volume should equal our length, which is 8, times our width, which was 3, times our height, which is 4. And we could verify that works. We would do 8 times 3, oops, let me clear that out. 8 times 3 times 4, and that gets us 96 like we thought it should. So that's kind of verifying that we got that right. Now, in our next page, we are going to be solving volume problems with cylinders. So this part's a little bit trickier. We've got to look for the formula that we want, and again, I filled those in for you on step 1 each time. Step 2, you're going to replace the formula equation with the appropriate numbers, and then step 3, solve and label with the correct unit of measure. Remember that we will be using 3.14 to estimate pi, so please don't use the pi button if you are if you are using this calculator. There is a pi button here. We don't want to use it. We're just going to use 3.14. So, for example, we're going to find the volume of this cylinder. The radius is labeled as 4, and our height is labeled as 12. So I fill this in by saying volume will equal pi, which is 3.14, times my radius squared. Now this is where it gets a little tricky. Remember that squaring a number means multiplying it by itself. So radius squared also means we could have rewritten this whole thing as 3.14 times r times h. And I'm going to rewrite that in our font that we're using to make it a little bit clearer. That's going to show us here that when we are multiplying, and it doesn't want me to do that. Okay, so when we're multiplying by r squared, remember squaring r just means multiplying it by itself. So you can think of that part there as just multiplying the radius by itself. So we're going to say if we're doing 3.14 times r squared, r is 4, so I'm just going to multiply by 4 twice. And that's in there, and the parentheses is like what we're doing for our exponent there. And then to multiply by the height, we have to multiply by 12. So then all we have to do is just multiply all of this together in the calculator. So we have 3.14 times 4 times 4 times 12, and that gets us an answer of 602.88. No rounding is needed because we had already rounded pi to the nearest hundredth there. So we're going to label this again with centimeters cubed. Now, the reason I left you this extra line here is because you could have rewritten this part, and instead of just leaving it as 4 by 4, if you want to think of r squared as being 4 squared, well, 4 squared is 16. So you could have plugged in the 16 for that step and then just multiplied all of that together in the calculator. You're going to get the same answer regardless. So if you want to pause the video and try the next one, feel free. Right now our radius in this is 15 inches and our height is 13 inches. So to plug this in, we say volume equals pi, which is 3.14, times our radius squared. And this time I'm going to show it to you with the exponent on it. So if you want to do the exponent, you can do what I'm doing and copy and paste that. Delete the r and plug in 15 instead. And then I'm going to do times the height, which is 13. And there goes my font again. So let's change that up again just to make it look nice. All right. So now all we have to do is multiply, and we have an exponent. So we have to remember the rules of GEMDAS. So before we can multiply, we have to do our exponent. So I'm going to say 3.14 times, well, 15 squared is 225, and then I multiply that by 13. So then over in my calculator, I'm just going to type in 3.14 times 225 times 13. So I get an answer of 9,000. So volume equals 9,184 and 5/10. And again, that is going to be centimeters cubed, or you can write cubic centimeters. Finally, in our last example, we have a missing length again here. So it's saying to find the height. We know that the volume this time is given to us as 1,130 and 4/10, and the radius is labeled as 6 centimeters. We're trying to figure out the height. So this is a cylinder that we have an example of where it's on the side. So it doesn't really look like that's the height anymore, but we know that the x here is definitely not our radius because the radius is always in the circle. So this is our other attribute of the cylinder, and even though it doesn't look like height, that is what it is. We're going to plug in what we know here. So we know that our volume this time is 1,130.4, and then I write my equal sign, and then the next part of my formula is pi, so I fill in 3.14 times my radius squared. My radius squared is 6 this time, so I'm doing 6 squared. So again, I'm going to show it to you with the exponent. So we would plug it in like this, so 6 squared, and then times our height. So times h. Now we don't know h, so we're leaving it as that variable that we're going to solve for. So what you can do here, and if you haven't tried this already, to figure out what 6 squared is, you can type in 6 squared like this with that a squared button and press enter, you get 36. Or if you want to just do it all in one step, we can say 1,130.4 equals, and then I'm going to type in 3.14 times 6 squared. So I'm going to say 3.14 times 6 squared. And I'm going to make sure that I put parentheses around the 6 squared to make sure that that is just on its own there. Desmos should know to follow GEMDAS, but you want to verify that it does by putting parentheses around that. So that part gets us 113.04 times our height. Now again, we are looking to figure out what h is. Because we're multiplying h by 113 and 4/100ths, the opposite of doing that would be to divide both sides. So we're going to divide, if I can type, we're going to say divide both sides by 113 and 4/100ths. So that's our step that we're going to do. Again, it's really hard to type that in the Google Doc, so we're going to leave it like that. If we did that, 1,130 and 4/10ths divided by 113 and 4/100ths gives us an answer of 10. So on this side, I get 10. And then over here, if I divide 113.04 times h divided by 113.04, you're taking that number and dividing it by itself. That gets you 1, and 1 times h would just be h. So 10 equals h, which means the height is 10, and we were measuring in centimeters. And to verify, you could plug it all in and say that 3.14 times the radius squared, so 6 times 6, and then multiplied by our height should get us our other answer. And if we go through and just double check that on our calculator, we should get that answer of what they gave us, 1,130.4 cubic centimeters, which is what had been given to us. So there's your introduction on how to do volume problems. Please use the Desmos calculator while you're doing the rest of your work. Remember to continue using 3.14 for pi, and always label your answers as cubic centimeters or centimeters cubed. Thanks for watching.